All right, so we're back, guys. So as I was saying earlier on, the different types of fraction that we have proper, imp, and mixed. Now we say that we call a fraction proper when the numerator is smaller than the denominator. And we say why that is proper, because of the definition of a fraction is a part of a whole. And so we should clearly be able to take out some amount of parts out of a whole. Now for a fraction, the numerator tells you how many parts you have out of the whole. The denominator tells you how many parts the whole is cut up into. All right, and in this case, if you have a circle and you cut it up into 4 parts, the denominator also means that you're cutting it up into 4 equal parts, right? Now, if you have where the numerator is larger than the denominator, then it is no longer a proper fraction. Instead, we call it an improper fraction, right? So it is still referred to as a fraction because the parts are parts of wholes, not just one whole, but 2 wholes. So if you have 9 out of 8, the 8 tells you that each whole is cut up into 8 parts. But if you are to get 9 parts out of one whole that consists of 8 parts, that is impossible. We have to get another part out of another whole in order to get 9 of the same slices of parts. But so in that respect, we would call it now an improper fraction. So what we notice about improper fraction, the numerator is larger than the denominator. But why it is okay? Because the numerator is telling you that the number of slices that you have there out of the whole, say for instance, here we have 9/6 as an improper fraction. So 9/6 tells you that one whole pizza will be cut up into 6 parts. But if you have a fraction where you have 9/6 parts, it doesn't mean that the 9 is taken out of one whole pizza. It has to be taken from 2 pizzas. So you have 6/6 coming from one pizza, and if you get another pizza and you take out 3 more slices, now you have a total of 9 slices. So even though we have 9/6, it doesn't mean that the 9 is coming out of one pizza. It means that you're coming out of more than one pizza. And that is the reason why we can easily convert improper fraction now to what we call mixed fraction or mixed numbers, because here now the denominator tell you now how much slices one of the whole going to have. And so to find out how many wholes we can get out of this mixed number, we simply divide the numerator by the denominator to see how many 6 can come out of 9. And if you do that, you'll realize you can get only 1 6 out of 9. And when you take out that 1 6, that means you take out 6 slices out of 9 slices. And how many slices remain? So we have 3 slices out of 6. Is that correct, guys? Is that correct? And so this is the same as 1.5 slice pizza. So you have one whole pizza.
Sorry, couldn't simplify some more.
Yeah, so I just simplified it a while ago. So you have one whole pizza will be represented by the whole number, and you have half a pizza, which should give you the extra 3 slices. Is that clear, guys?
Yes, sir.
Right, and so where you have a fraction where the numerator is greater than the denominator, we don't refer to it as proper, right? It has to be improper. The proper fraction is when you can get the number of slices out of one whole. So with proper fraction, you really don't have any whole parts with it. You just get the number of parts out of the whole. So in the case of 3 out of 4, that has no whole to it. It's just 3 parts out of 4. So that is just 3/4 pizza. You don't have one whole pizza here. All right. So improper, we often convert them by dividing the numerator by the denominator to see how many parts that we can get out of the numerator. And that, in this case, we get 1 whole and a half pizza. And so this becomes a mixed number. And we call it mixed number because we have what? Why we call it mixed number, guys? Because we have fractions mixed with whole numbers. Is that clear? Is it clear?
Yes, sir.
Yeah.
Yes, sir.
Right. Now, the other type of fraction that we looked at before this, where the 2 slices would be the same. So we would say 8 over, sorry. We say 2 over 8 would be the same as 1 over 4. All agree? All agree?
Sir, repeat. I wasn't hearing you just now.
I said 2 over 8 is the same as 1 over 4.
Yes, sir.
Right.
Yes, sir.
And the reason why they are the same is that if you have the same fraction cut up in 8 parts and you take out 2 parts, it would be equal to the same fraction cut up into 4 parts, where 1 part of 4 is the same as 2 parts of 8. And you could easily demonstrate that if you have, let me see if I can give some clarity to that, because you see, we often use these concepts and we never really take the time out to truly see what is really happening from a picture point of view. All right, so from a picture point of view, if we cut this up, into 4 slices, and if we cut up the same pizza, we cut up into, now kind of doing it like this so that you can see that the 4 slices that we have, that we cut it up into, we only cut up the 1 pizza into 4 slices. But if we now if we're cutting up the same pizza, into 8 slices. Now, if we are to shade 1 out of 4, or a quarter, we would shade this portion. to be a quarter pizza, right? But we notice that when it is cut up into 4 equal parts, this part would be 1 part out of 4. But when you cut it up into 8 equal parts, we realize that the 1 part out of 4 cut into 2 parts to give you 2 parts of 8. So this is 1 part of 8 plus another part of 8. So another slice out of the 8. And when you put those 2 slices out of the 8, it would be the same as the 1 slice out of 4. Everybody see that? Everybody?
Yes, sir.
Showing you from a picture point of view? So the green shaded part would be the shaded area. If you cut it up into 4 parts, that green part would be 1 slice out of 4. And the same shaded area that you have in the green parts, if you cut up the pizza into 8 parts, that shaded area now becomes 2 parts out of 8. So 2 parts out of 8 is the same as 1 part out of 4. So in other words, we can say two over 8 is the same as 1 over 4. And so these 2 fractions are equivalent, meaning they're exactly the same size. Any question to that? Everybody's clear on that? Everybody's clear?
Yes, sir.
All right. Now, one of the things that we should be able to do with the fractions, we saw where we have mixed numbers and we saw where we have improper fractions. Now, we should, because both of them somewhat related to each other, it means that we can always convert from one to the other. So here, if we are to change a mixed number or a mixed fraction, which is 2 over 2 and 4 over 5, and we are to change that now into an improper fraction. We're to change that into an improper fraction now. How do we go about doing that?
Multiply, sir, the denominator by the whole number and then add the numerator.
All right. Anybody else agree with what Ms. Waysam is saying?
Yes, sir.
Right. Because we know that the whole number is telling you, if we are thinking in terms of pizza, the whole number is telling you that you have 2 whole pizza, and then now you have 4 slices out of 5. So if each of the pizza was cut up into 5 slices, then you have 2 of them cut up into 5 slices. So 2 would give you how many slices in total?
10, sir.
10. And so that's why now we multiply the 2 times 5, that will give you 10 slices. And then now the 2 slices of the two whole have 10 slices, and then we have this extra slices is 4. Now we have to add that extra 4 to the 10 slices to give us how many slices in total?
14.
14. So it means that 2 pizza and 4 extra slices, where the pizza cut up in 5 parts, will give you an improper fraction of 14 slices out of 5. Is that clear, guys? Any question? So we should be familiar with how to make these conversions. All right. Next, So what we do in the process is that we multiply the what? Multiply the whole number by the denominator, then we add the numerator. And so that is the procedure when we are converting fractions, mixed number, mixed fraction into improper fractions. All right, here we now want to convert an improper fraction back to a mixed fraction. What is the procedure here? Anybody?
Sir, repeat.
Now we want to change this fraction, which is an improper fraction, which is 25/7. We want to convert this now to a mixed number. What is the procedure that we follow when we're doing this? What must we? What?
We divide our numerator with the denominator. Or the denominator with the numerator.
Yeah. Divide
the 7 into 25, sir.
By the numerator by the denominator. Now remember what we are saying, how many 7s can come out of it? We're dividing the numerator. So 7 into 25 goes how many times? How many 7 you can get out of it?
3, sir.
3. So it means that in terms of the whole numbers, you can get 3 whole numbers.
3 times.
Right. So 3 whole numbers. That means if you're thinking in terms
And
of
4 remainder.
you will get 3 full pizza that is cut up into 7 parts. Plus now, how we would find the remainder after we take out 3 parts. Now we will say 3 times will give you what? 3, 7 give you?
21.
Right, so we know slice has 21. So up in the numerator where we have 25 now, we take away 21 from 25 and how much we make?
4.
We put the 4 extra parts now over the 7. All right, and so that is the principle behind the conversion. Any question? Everybody is clear on these? Raise your hand if you understand these processes, guys. How to convert from mixed to improper and how to convert from improper to mixed. I'm only seeing 2 persons, only 2 persons understanding how to do these. Raise your hand if you understand how to convert from mixed to improper and also to convert from improper to mixed. All right. So, moving on. Now, the second process, we divide the numerator by the denominator. So we say 25 divided by 7, we get 3. 3 parts, and then remainder 4, right back the 4/7. So it's 3 whole number and 4 parts out of 7. All right, here now we're going to be looking at adding and subtracting fractions. So we just look at the different types of fraction that we can have here. So we have proper, improper, and mixed. And we also saw where we have equivalent fractions. All right, so we know what equivalent fractions are. So let me ask somebody to tell me, what are equivalent fractions, students? Anybody? Can anybody tell me?
A fraction, so I'm not sure, but I'm trying. A fraction that has the same numerator and denominator?
Oh.
Okay.
A fraction that have different numerator and denominator but have the same volume.
All right, so Give me a second, students. I'm just checking on who is trying to, okay. All right, so it would be two fractions that are of the same size, but they are expressed with different numerator and denominator. All right, so a quarter.
Sir, could you repeat, please?
Equivalent fractions are fractions that have the same size, the exact same size, but they are expressed with different denominators and numerators. Is that clear to everyone? Raise your hand if you understand what was just said, students. Right, so if we have a quarter and we have 2/8, the two of them are the same size, but the denominators that both fractions have, they are both different. The numerators that they have, they are different, but we say that the numerators are equivalent and the denominators are equivalent. So the entire fractions, both fractions are equivalent in terms that they are the same size. So in other words, they are the same size fraction which are described in different numerators and denominators. Same fraction described with different numerators and denominators. And that is the reason why we are able to simplify fractions. Because when we're really simplifying fractions, we're really finding the simpler form of equivalent fraction. That's what we're doing, you know. Because if we have 2/8, and I say to you, express this in its lowest term, then what you're going to give me is a fraction that is equivalent to this, but with a smaller numerator and a smaller denominator. So you would say a number that can go into 2, 2 can go into itself 1 time, 2 can go into 8 4 times, and so 1/4 would be the simplest form of this fraction 2/8, right? So when you're expressing fraction in their lowest term, you're looking for an equivalent fraction with smaller denominators and smaller numerators. That's what you're doing. Is that clear, guys? Raise your hand if you understand. All right, good. Now moving along. We're now going to be looking at addition, subtraction, or fraction. Now, if we are to add fractions, there are some rules that we have to follow. All right, so the first rule of adding fractions is that only fractions with the same denominators can be added or subtracted, right? Now, why is it that you think we need, when we're adding or subtract, why is it that we can only add or subtract with the same denominators? Can somebody tell me why?
Sir, repeat.
It says only fractions with the same denominator can be added or subtracted. That's the first rule. They must have what? The same denominator when you're adding them or when you're subtracting them. And I'm asking you why. Why is it so? Why do you think that we can only add them when they have the same denominator? And why can't we add them when the denominators are different? So why can't we add 1/4 plus 2/8. If we had to add these, how would we add these, students? Explain to me, how can you add these?
So you have to find an LCM for this one.
Right. So the reason why we have to find an LCM is because the denominators are not the same. Why can't we just go ahead and just add these like how they are?
They're not from the same whole, sir.
They're not from the same whole. That means each slice would not be the same size.
Right.
The denominator tell you how many parts the whole is cut up in.
Yes, sir.
Right? But when you think about the equivalent fraction of these two, we now know that 2/8 would be the same as a quarter, right? So if we write 2/8 as a quarter, now we would be able to add 1/4 with another quarter. And we know that these two fractions, they have this equal size. And because they have equal size, if we have one of them and then we have another one of them, then now we have two of them. So we have 2 quarters. Everybody see that? And if we are to find an equivalent fraction for this, to simplify it, we would say what can go into 2 and 4? Then we say 2 into 2 goes 1, and 2 into 4 goes 2. So an equivalent fraction to 2/4 would be 1/2. So if you add 1/4 plus another quarter, it would be equivalent to half of the pizza. Is that clear, guys? So, yes, Ms. Wason. So for that reason, the rule stands that only if the fractions have the same denominator, that's only time when we can add them or subtract them. So that's rule number 1. Now, rule number 2 says that if the denominators are the same, we just simply add or subtract the numerators. So I know that, some people might say, oh, it is pretty straightforward. You just add the numerator. But I can tell you, I see where students add the denominators too. So when you're adding fraction, you're not adding the denominators. You're adding the numerators and you put it back over the same denominator. So here we have 1/7 plus 2/7. Both of them have the same denominator. And to add them, we just simply add the numerator. So 1 plus 2 gives you 3. So we have 3 out of 7. So this is telling you have 3 slices out of 7 parts. All right, guys, any question? All right, moving along. If now the denominators are different, if they're different, that means they're not the same. We know that the slices are not the same size. So in that case, we can't add them. We only can add them if the slices are the same. Now, I want to look at this example, 5/6 minus 3/4. I'm going to look at this example, 5/6 minus 3/4. And this way, some would have already alluded to how to solve this, and we would have to do what Ms. Wilson. This one is what, 3/4?
Yes, sir. By the LCM.
So we would have to now find the LCM. Anybody know what LCM means?
Lowest common multiple.
All right, lowest common multiple. Now, why is it that we need to find the lowest common multiple? Why do we find the lowest common multiple, students?
Sir, so we can get the answer in its simplest form.
Not really, because if the denominators are different, we're trying to find the LCM that we can express the two fractions with the LCM as the denominator. So we are really trying to do what? What you said just now, Ms. Laysom?
Sir, I was saying so we can work it out in its simplest form, you know? Because you know, if we even use for this one, sir, we know that 12 would have been the lowest common multiple, but you know, if you can also use 24, but then after you use 24, you would have to break down, you'd cancel it down, and the same result you'd get for 12, you'd have gotten it then. Just the same after you cancel it down some more.
All right, so I understand exactly what you're saying. So when you're saying the lowest form, you're saying that you're trying to find fractions in their equivalent form, the lowest equivalent forms. That's what they're—
Yes, sir. Yes, sir.
the lowest equivalent forms. And so if you think about it, these two denominators are not the same. So we can't add them, because if the denominators are different, it means that the slices are different. So if you have one whole and cut it up into 6 parts, each slice they're going to be smaller than the whole if you cut it up into 4 parts. So the slices are not the same. You see, and we cannot add slices that are not the same. We want to add slices that are the same. So these two denominators, 6 and 4, what we want to do is to find a number that these slices can fit into. So which number 6 and 4 can fit into without a remainder? So what is the LCM of 6 and 4? Ms. Waysom?
12, sir.
12. All right. So when we say 12 is the LCM, why we say 12 is the LCM? Miss Trivia, why 12 is the LCM?
Because 12 is the lowest common multiple that 4 and 6 can divide it into without leaving a remainder.
What it means to be the lowest common multiple, what that really means.
Sir, the lowest number that the denominators can be divided into.
All right, fair enough, the lowest number that the denominators can be divided into. But why do we call it the lowest common multiple? Anybody else?
Or is it the smallest number that the denominators can divide into without leaving a remainder? So would that be 2 or something?
Lowest common multiple. of 6 and 4. What is actually saying? What it is really saying? What are we looking for? What are multiples? What are multiples? Anybody? What are multiples? Can somebody tell me the multiples of 4?
4. Up to where, sir?
Just give me about the first 5 multiples of 4.
4, 8, 12, 16, and 20.
4, 8, 12,
12, 16, and 20.
15, and 20. All right, so these are multiples of 4. Why are they called multiples of 4?
Because 4 can be divided into those numbers, sir, without a remainder.
That's an idea, yes, but think about it. What are multiples? Tell me about 5 multiples of 6 here now.
6, 12, 18, 24,
12,
and 30.
18,
24 and 30.
24, and 30.
I saw 6 can go into 30.
6, 12, 18, 24, and 30. Give me another multiple for 4.
36, sir.
For 4.
Oh, for 4. Oh.
24.
24. All right. So multiples of 4 would be numbers when you multiply 4, but if you multiply 4 by the counting numbers, you're really getting multiples of 4. So you say 4 ones 4, 4 twos 8, 4 threes 12. So we call them multiple because you're multiplying the counting numbers by 4. And so you're getting multiples of 4. So this is 4 by itself is one multiple of 4. Then you have 8, which is 2 multiple of 4, 3 multiple of 4, 12, and so on. What about 6 here? Is the same thing. We are multiplying the counting numbers by 6. And so if we are counting by 4, and if we are counting by 6, we are really getting multiples of 4 and multiples of 6.